this subject chapter is vapor refrigeration system, and we are starting our lecture with the topic simple vapor absorption system. So before starting, I am just converting this document to another format. In simple vapor absorption system, we are always eliminating the compressor by absorber, then generator and eliminator. So in this vapor absorption refrigeration system, there is no compressor is present. Instead of compressor, we are using these three components, and the components like condenser, evaporator, receiver, throttling valves. These components are remain same whether in it is a vapor absorption system or whether it is vapor compression system. Here we are only replacing the generator with another three components, which is absorber, pump and generator here. So what are the function of these three, absorber, pump and generator? I already mentioned here. You can see on your screen. Yeah. Vapor absorption system. Vapor absorption refrigeration system. The compressor of a vapor compression refrigeration system is replaced by use of absorber, pump and generator. Absorber, it absorbs the refrigerant vapor by its weak solution in the suitable absorbent. Pump, it raises the pressure of rich solution received from absorber up to the condenser pressure. Then generator, it produces high pressure NH3 vapor. Here refrigerant, it is in the form of ammonia NH3 and we are using absorbent as water here. Here we are not directly compressing the NH3 vapor because the compressor required for NH3 high compressor work is required. So we eliminate the compressor and replace it by using absorber, pump and generator. Now we are going to see the working here. High pressure NH3 vapor from generator is passed to the condenser. In condenser, the vapor of ammonia is condensed. This high pressure liquid ammonia is then passed to the control valve, which is expansion valve. Expansion valve reduces the pressure of liquid ammonia and pass it to the evaporator. In evaporator, this liquid evaporates, and this low pressure vapor ammonia is allowed to mix and absorbs in absorbent with mixed solution of aqua ammonia and makes it into strong aqua ammonia solution. This strong aqua ammonia solution at low pressure from absorbent is pumped to the generator. Okay, and the generator, the strong aqua ammonia solution is heated and high pressure ammonia vapor are produced and cycle is continued there. Okay, I am going to again explain this working in the diagram here. Just look on it. We are starting here from this strong aqua ammonia solution. The strong aqua ammonia solution from this absorbent here, from this absorbent is absorbed by the its pressure is raised by the pump to the generator pressure. Okay, and in that generator, with the help of heating coil, what we are doing, this strong aqua ammonia, so from this strong aqua ammonia solution we are producing high pressure NH3 vapor. This high pressure NH3 vapor are moves toward the condenser, and after removal of this ammonia from this strong aqua ammonia solution, this aqua ammonia solution becomes weak, and this weak aqua ammonia solution is again we are passing it to the absorber one. Here you can see this is the absorber. We are passing this strong weak aqua ammonia solution to the absorber, and what is happening here I will tell you at the end of this cycle. Now we are coming here again. This high pressure NH3 vapor are moving toward the condenser. In condenser they are losing their heat, or we are cooling this high pressure vapor. And when these high pressure ammonia vapors are cooled at the condenser, there is a phase change occurs, and this ammonia vapor comes to the liquid form. You can see here high pressure liquid. This high pressure liquid when passed through the expansion valve, and when it comes to the evaporator, it suffers pressure drop, and because of this pressure drop its temperature also drops. And due to due to drop in temperature, when this vapor come in evaporator, it absorbs heat from the evaporator and phase change occurs. Means what happens, this low pressure NH3 liquid when comes in evaporator, it changes its phase, and this liquid becomes vapor. And when these vapors are again we are passing to the absorber, and at absorbers this vapor ammonia mixes with this weak aqua ammonia solution, and we are getting this strong aqua ammonia solution. This strong aqua ammonia solution is again absorbed by the pump, and pump again increase its pressure to the generator pressure. Okay, and again we are heating it to remove the high pressure NH3 vapor, and we are sending this NH3 vapor to the condenser here, and again this cycle continues. Now it's time to show you its video animation. I'm going to show you.
Today we will discuss about
Visible animation.
absorption refrigeration system. Firstly, we will discuss about refrigeration. Lowering the temperature of an enclosed space by removing heat from that space and transferring this heat to elsewhere is called refrigeration. Refrigeration means extract heat from the space and lower the temperature of that required space is called refrigeration process. Firstly, we will discuss about parts of the vapor absorption refrigeration system. We have an evaporator, a condenser, expansion valve, and these are connected with the help of pipes, and a main component in the vapor absorption refrigeration system is vapor generator, absorber, and pump. In vapor compression system, there will be compressor instead of vapor generator, pump, and absorber. This is the main difference between vapor compression and vapor absorption refrigeration system. Evaporator is connected to the absorber with the help of pipe. Now we see the working of vapor absorption refrigeration system. What will happen? There in the absorber tank there will be ammonia and water. Ammonia will work as a refrigerant and water will be used as a absorbent. So absorber has both water and ammonia. Then this pump will pump this water and ammonia to the vapor generator, and in the vapor generator ammonia will convert it into vapor and water will come back to the absorber. Then these vapors will go to the condenser. High pressure ammonia vapor will reach to the condenser, and in the condenser they will lose their latent heat and convert it into liquid ammonia, and this liquid ammonia will reach to the expansion valve where reduction in pressure and temperature will take place, and this liquid ammonia plus vapor will go to the evaporator, and evaporator will extract heat from this liquid ammonia plus vapor and convert this liquid ammonia into completely vapor form, and this vapor form then go to the absorber again. So these low pressure vapor will go to the absorber, and this cycle will repeat again and again. So this is the working of vapor absorption refrigeration system. Thank you for seeing this video. For more updated videos, you can subscribe.
I hope you understand the working of simple vapor absorption refrigeration system. Now we are going to see another topic. So we are again to this return to this topic here. So we are going to see this next topic, which is practical ammonia vapor absorption refrigeration system. So there are some additional part we are going to use here in practical vapor ammonia practical vapor absorption system. So these parts are, you can see here, these additional parts are accumulator, you can see here these additional parts are analyzer, then rectifier, then we are using this heat exchanger here, and again we are using heat exchanger here. So these are the extra parts which we are applying to use the ammonia vapor absorption refrigeration system in practical life. Okay, so discussing about these extra parts, I am already explained here that after the generator, if there are some liquid vapors going along with this ammonia via this way, by this upward way, then there is one component we are joining here, which is analyzer, which restricts the go of liquid refrigerant along with the vapor ammonia. It allows only vapors to go outside, and rectifier, it is again cross check that if any vapor, any liquid droplet is going along with the vapor ammonia, then rectifier eliminate it and again send it back to the analyzer by this way. And this heat exchanger, it is just using to improve the or to reduce the work of heat coil in the generator. It is just a heat exchanger. Similarly, here we are using this heat exchanger just to reduce the temperature of this liquid ammonia, or we can say that just we are using this heat exchanger to produce the subcooling effect. We again have this in written format also. You can see here analyzer. It is possible that ammonia vapor leaving the generator may contain some water vapor which will be condensed in the condenser. The condenser water may freeze in expansion valve and choke the flow. Therefore, it is necessary to remove this moisture. So, analyzer is just to remove the moisture from ammonia vapor before entering the condenser. Here there is some construction detail of this analyzer. An analyzer consists of a series of tray mounted over the generator. It acts as an open type heat exchanger. High pressure strong aqua solution from the absorber via aqua heat exchanger along with the condensate remove in rectifier flow downward over the tray, and it cools the hot rising ammonia vapor from the generator. Therefore, most of the water vapor gets condensed and drips back to the generator. This method helps in salvaging a part of the total heat energy from the NH3 vapor, which would otherwise have been rejected in the condenser. Then here is the another component, which is rectifier. A rectifier is a water cooled closed cooler. It helps in condensing the last traces of water. If any water particles which will not eliminated by analyzer, then for this rectifier is used as it is a cross check or double check. This unit ensures only hydrous ammonia, i.e. dry ammonia, reaches the condenser. Then aqua heat exchanger, there are two types heat exchangers. The aqua heat exchanger, in this heat exchanger the strong but cold aqua solution being pumped back from the absorber into the generator and is brought in contact with the weak and hot aqua ammonia solution. Here liquid vapor heat exchanger, it helps in reducing the temperature of the liquid ammonia in approaching the expansion valve so that an increased refrigerant effect is obtained in the evaporator. Okay.